In section 5.6, which is titled The Fundamental Theorem of Algebra, we see something that we've been practicing basically throughout our chapter. So the fundamental theorem of algebra says that the degree tells us the number of solutions. Okay, that's what our fundamental theorem of algebra tells us. Now we are going to take that, take this fundamental theorem and make sure that when we are solving some of our more complicated polynomial equations, we are finding all of our solutions. So we would see an example like this. So example 1, what are all the roots of x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. Now, if you look at this equation, there are a lot of terms, and we don't know how to solve something that looks quite this complicated. All right, so if I think of the strategies we know, well, maybe I could factor by grouping. That's one of my strategies we can use when I have a lot of terms here. But if I tried to group in pairs, okay, I don't really know how that's going to work. Or if I group in threes, like can I group with 3 groups of 2? Can I group in 2 groups of 3? I don't know. So let's not try that strategy. Instead, let's remember that rational root theorem. We can use our rational root theorem to help us solve some of these more complex equations when we don't know how to solve it without. So our rational root theorem, again, we want to list out our possible numerators and our possible denominators. My possible numerators are my numbers that multiply to the 4 here. So it could be 1, could be 2, could be 4. My possible denominators are numbers that multiply to my coefficient here at the beginning, which is just 1. So my possible roots could be plus or minus 1, plus or minus 2 over 1, plus or minus 4 over 1. And I should say these are my possible rational roots. So we're kind of keeping our fingers crossed here, I guess, that one of these actually is a root, and we can use that to keep solving our equation. So the way that we check, if you remember our graphing calculator process, we need to go to our calculator and type our equation in here under y equals. There we go. So my equation again was x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4. Make sure under second table set, that your independent is set to ask, which it is, and then we can go to second table and put all of these possibilities in. So our possibilities, again, we had plus or minus 1, so I need to check 1, and hey, 1 is a root. And as soon as we find one of our roots, use synthetic division. And then hopefully, after we do our synthetic division, hopefully we'll be able to factor the rest of the way without having to check all of these rational roots, because maybe there are more, maybe there aren't. All right, so when we do our synthetic division, whatever I know is a root goes straight into my box. Okay, because really if 1 is a root, that means x minus 1 is a factor. So 1 goes in my box. My coefficients across the top, I have 1x to the 5th, negative 1x to the 4th, negative 3x cubed, 3x squared, negative 4x plus 4. And again, with our synthetic division, we bring our 1 down. Take this number times what's in the box. 1 times 1 is 1. Add down. 0 times 1 is 0. Add down. Negative 3 times 1 is negative 3. Add down. 0 times 1. Add. Negative 4 times 1 is negative 4. Now this is my remainder, my 1s, my x's, my x squareds, my x cubes, my x to the 4th. So all in all, this ends up being x to the 4th plus 0x cubed minus 3x squared plus 0x minus 4. And I need to find when on earth is this going to equal 0? So let's think for a second. Can we use other factoring strategies? And whenever I have an x to the 4th term, an x squared term, and then a number without an x, my first thought is this a fake quadratic? Are there numbers that multiply to negative 4 and add to negative 3? There are. So we factor with x squareds. My numbers that multiply to negative 4 and add to negative 3 are negative 4 and positive 1. So now I can set each part equal to 0. X squared minus 4 equals 0 when x squared is 4. Square root both sides. X is plus or minus 2. X squared plus 1 equals 0 when x squared is negative 1. Square root both sides, we get x is plus or minus the square root of negative 1, which is I. And then we already knew that 1 was a root. So the fundamental theorem of algebra says that my degree is the number of solutions. I have a degree of 5 here, which means I'm going to have 5 solutions to my equation. And if you count out what we have 2 here, 2 more, and then 1 more. So I have my 5 solutions. This problem is done. So really the overall goal, the overall process, we use our rational root theorem to find a root, synthetic division, other strategies to factor and solve the rest of the way. So this process really is combining a lot of what we have learned this chapter.